So here's our second video for Unit 9, and this is going to cover just balancing chemical equations and give you a couple of examples on how we go about doing this. Okay, so I'm going to go back to actually an example we had in the first video, but just trying to show you exactly what we're trying to do here. The law of conservation of mass states whatever goes in has to come out, so we have to have the same going in. And if we see here, we have 2 aluminum on this side, and then over here in our balanced compound, we have 2 aluminum over here, 3 bromine gas, but if you notice there's a 2 on the subscript, so we actually have 6 bromine here. And then we look over here, there's a 2, there's a coefficient there in front, and there's a 3 subscript here for a total of 6 bromine as a product. And there's a few steps to go about doing this. So, of course, I like to give you guys steps to make sure you know, have a reference to go back to when you get stuck. So, first of all, when I'm balancing a chemical equation, I'm going to use something called a coefficient. And that coefficient is a number that's written in front of the species or in front of the compound or molecule. And when we balance a chemical equation, we always use the lowest whole number ratio. So we've had this idea before. If you can reduce that ratio, by all means, please do. If you have coefficients that are 2, 4, and 2, those would reduce to 1, 2, and 1. So it's just like reducing a fraction. We do that for our coefficients in a balanced chemical equation as well. Okay? So, first step, we're going to write a skeleton equation and make sure our chemical formulas are correct. And I really can't emphasize this enough. You have to make sure those chemical formulas are balanced. If they're not, it's going to make your chemical equation almost impossible, if not impossible, to balance. In fact, I would even venture to say if you're having a lot of difficulties balancing a chemical equation, you need to go back and double check your formulas. Okay. The other thing we do in this first step is to put in our symbols and physical states. So we're going to look at our word equation down here. I've got liquid sodium carbonate plus aqueous calcium chloride yields, so this is our arrow sign here, solid calcium carbonate and aqueous sodium chloride. So we're going to build all those formulas here. And if you look on step 2 here, right at the bottom of the slide, here are the formulas for those words that we had in our word equation on the previous slide. Notice when I have this all listed here, I don't have it balanced, but I do have the physical states next to each one of them as listed in the word equation. So in this step, we are going to count the atoms of all the elements in the reactant side. And this second part here is just a helpful hint. You want to group any kind of polyatomic ions together as a single substance. And here's what I mean by that. So right here, if you look, here's carbonate, CO3, okay? That's an anion, a common anion of ours. And if we look over here on the product side, here is carbonate again, all intact. Notice the carbon and the oxygen did not separate. So carbonate is carbonate as a reactant and a product. So we're going to group them together when we start to balance them as well. So I'm going to list these over here. I've got 2 sodiums, 1 carbonate, 1 calcium, and 2 chloride. So as you might have guessed, the third step is doing the exact same thing as the products. I've got 1 calcium, 1 carbonate, again keeping that group together, 1 sodium, and 1 chlorine. So the fourth step is just changing these coefficients to make sure they balance. And if you listed everything for steps 2 and 3, the big thing that you would have noticed is over here on this side, my sodium, I have 2 on this side. But over here on my product side, okay, I only have 1 sodium. So to change that, I need to put a coefficient in front of sodium chloride, okay? And that means I'm going to have 2 sodiums and 2 chlorides now over here. Okay, so this changes. Now, if you noticed, I have 1 carbonate as a reactant, 1 carbonate as a product. I don't need to do anything with that. 1 calcium, 1 calcium. And now because I've put that 2 coefficient in front of my sodium chloride as product, now my chlorine, because I have chlorine, 2 chlorines over here as a reactant, and now I have 2 chlorines as a product. So now I'm balanced. And we would say that this has a 1, a 1, a 1, and a 2. That would just kind of be a quick way to communicate that the coefficients on this equation here. Okay, the last thing to do is to always make sure that you are in your lowest possible ratios. And since our balanced equation was a 1, 1, 1, and 2, that is the lowest possible ratio for that reaction. It's always nice to go back and check the math, make sure that you're correct. So there's always a way to go back and check your answer. Okay. And the other thing I included here on the video is just a visual, kind of a map of steps. I've gotten some feedback that this is really helpful for some of you, so I included this on the presentation as well as the notes. So if you notice, it has all the steps here, skeleton equations, and breaks down the steps even a little bit further. So hopefully a good reference tool. And the last thing I'm going to do is do an example with you guys. I want to take this word equation and take it all the way to a balanced equation. So I'm going to take this word equation and we're going to start building our formulas. So I see it says aqueous sodium hydroxide. Okay, I know that sodium is a +1 charge, so I'm going to put sodium here. And hydroxide, if you look on your anions list, it is OH, and it is a 1- charge, so that's balanced. And that is aqueous, so we'll put AQ there. And a plus sign. Now the second thing here is calcium bromide. So calcium is in group 2, so it's a 2+ charge. And bromide is in group 17, so it is only a -1 charge, so we're going to need 2 of those. And again, this is aqueous. And then we have a yield. So this means an arrow. And one quick way to do that is 2 dash marks and a greater than sign. Okay, and then it'll change to that arrow there. And this yields calcium hydroxide. So again, calcium is that 2+ charge. Hydroxide is a 1- charge, so we'll need 2 of those grouped together. And since this is a solid, we're going to put parentheses around an S, a plus sign. And our last product here is aqueous sodium bromide. So sodium, 1+ charge, bromine, 1- charge, AQ. All right, so this is my first step here. I went from a word equation to a skeleton equation. I've got my physical states, but I don't have any coefficients. So step 2 and 3 is about listing all of the elements that I have as a reactant and all of them as a product. So I have sodium, I have 1 sodium, okay. I have 1 hydroxide, and again I'm going to keep those grouped together because I see that hydroxide is intact on the reactant side and the product side. I have 1 calcium, and finally 2 bromine or bromide. Okay, now we're going to go to step 3 and we're going to do the exact same thing on the product side. I have 1 calcium, I have 2 hydroxides, so this is different than the reactants. I have 1 sodium, and I have 1 bromide. Okay, and then we're just comparing here. And the first thing I notice is I've got 1 hydroxide on the reactant side and 2 on the product. So to change this, notice I'm not going to put a 2 on the subscript because that would unbalance my formula. Instead, I'm going to put a 2 right here as, it doesn't show up very well. I'm going to put a 2 here as my coefficient to say I've got 2 sodium hydroxides going in here. Now, that's great that I changed my hydroxide, now I've got the same number of hydroxides, but if you notice, that also changed my sodiums. So I'm going to have to change that. And now my sodiums are off. So now I'm back over here on the product side, and I'm going to have to put a 2 here. And keep in mind, this is balancing equation is oftentimes kind of a trial and error kind of thing. Oftentimes you have to kind of go back and forth and change your coefficients until you get something to work. So I fixed my sodium problem, but now I've made my bromine 2. Okay, let me fix that. Okay, and if we look, I've got 2 sodiums, 2 hydroxides, 1 calcium, and 2 bromides. So I am balanced. So we would say that this is 2, 1, 1, 2. And that's exactly what we have down for an answer here. So this is the end of this video. I hope you found this helpful. Of course, we're going to do lots of practice of balancing equations in the classroom, but I wanted to at least get you an introduction and also a reference just in case you get stuck a little bit later down the road. Okay, see you tomorrow.